In Cisco's CCNP Collaboration curriculum, a topic that I don't think gets the attention it deserves is H.323 gateway configuration. Back when it used to be the CCNP voice track, there was an entire course. I taught it for many years. I wrote 3 different versions of the book for Cisco Press. It was called CVOICE, and that really got into gateway and gatekeeper configuration. And while it's still touched on in the current CCNP Collaboration curriculum, it's not given the attention that it used to be given, and it's critical. You need to know how to get through an H.323 gateway or some other type of gateway or trunk to get off of your network. So in this video, I wanted to share with you a fairly lengthy demonstration. I think it's going to be about a half an hour or so. That's going to show you from scratch how to set up an H.323 gateway to work with a Cisco Unified Communications Manager, how to place an inbound call coming in from the PSTN through that gateway into the Communications Manager, how to use some debug output to see what's really going on. Now, this video you're about to see, it's a sample from my CCNP Collaboration video training series. So if you like this one, you might want to check out the entire training series. I'll give you a link at the end of the video for how to go check that out. But for now, let's get into our discussion of H.323 gateway configuration that can translate between things going on the Communications Manager side and things going on the PSTN, the Public Switch Telephone Network side. Back in your CCNA Collaboration studies, one of the primary focuses was getting a Communications Manager server up and running for a single site. Phones within that site could call one another. We had various features we could add. We could integrate with voicemail. However, here at the CCNP level, a primary focus is getting out of our local site, out to the PSTN, out to other sites. And in this video, we want to see how we can, using this topology, configure router HQ as an H.323 gateway. That's a standards-based protocol. It's been around for a very long time, and we can configure that router as an H.323 gateway, and it can take calls coming in from the public switch telephone network and forward them to our Communication Manager servers at the HQ site. It can take calls placed by an IP phone, and a Communications Manager server can send the call to the HQ router, and it can forward it out to the PSTN. And we've got work to do in a couple of places here. We have to do some configuration on the HQ router, and we've got some work to do on the Communications Manager server. Let's begin on the HQ router. The first thing we want to do here on the router is say, to what type of ISDN switch are we connected? ISDN, that's Integrated Services Digital Network. That's typically the type of digital connection we're using to go out of a gateway out to the PSTN. And it could be based on a T1 circuit, or it could be based on an E1 circuit. If it's a T1 circuit, we've got 24 channels total, and the 24th channel is used for signaling. If we've got an E1, we've got 32 channels total, but the first channel is used for framing and synchronization, and the 17th channel is used for signaling, giving us 30 usable or 30 voice-bearing channels on an E1 and 23 voice-bearing channels on a T1. Well, we want to set this up for a T1. But first, let's say to what type of ISDN switch are we connected? I'm going to say ISDN switch-type primary-NI. Now I need to tell the card in this router that I want you to be a T1 instead of an E1. And we can see what card we have installed and where it's located physically by saying show inventory. I've got a Cisco 2911 router, and here we see my T1 or E1 card. It's a VoiceWIC version 2 card, 1 multiplex trunk, meaning there's 1 port, not 2 ports in this card, and it can be configured as either a T1 or an E1. It's in slot 0, meaning that it's being controlled by the motherboard. On a 2911, there are 4 WIC slots in the back of a router, and those 4 slots are controlled by the motherboard. They're considered to be in slot 0. Subslot 0 says which one of those 4 slots contains this card. There are 4 of them numbered 0, 1, 2, and 3. I'm in the first one, subslot 0. And because there's only 1 port on this card, and the port numbering starts at 0, that means that my T1 controller is going to be 0/0/0. Now I need to go in and tell the router that I want this card to act as a T1 module. I want that port to be a T1 port, not an E1 port. Here's how we do that. We go into global configuration mode and we say card type is going to be a T1 for the card in slot 0 and in subslot 0. Be a T1, not an E1. And because a T1 circuit is a synchronous circuit, we've got to set up some clocking. Here's how we can set that port up for clocking. We give a couple of commands. We say network-clock-participate, and we want to participate WIC slot 0. Next we'll say network-clock select, and I've only got one port. I'm going to say the priority is 1, and it's for T1 0/0/0. Now we're saying that this is participating in clocking. Excellent. And now we're ready to go into controller configuration mode. Not interface configuration mode, but controller configuration mode. I'm going to say controller T1 0/0/0. And a few things we might want to set up. We might want to set up the line coding. I'm going to say line code, and we could choose either B8ZS or AMI. The way AMI works is it tries to have an average of 0 volts on the wire. In other words, when it sends a binary 1, one time it'll be a positive voltage, and the next time it'll be a negative voltage, and the next time it'll be positive, and the next time it'll be negative, and we can just have no voltage representing a binary 0. And that works pretty good. However, there is an issue with AMI. There can be some confusion if we have a byte containing all zeros. We've got this big period of time where there's no voltage on the wire. And some equipment can have a bit of a challenge knowing, hey, what bit are we on? I kind of lost count there during all that period of silence. So B8ZS addresses that. B8ZS creates a couple of bipolar violations. In other words, if we need to send a byte containing all zeros, with B8ZS, even though the previous binary 1 was a positive voltage, let's say, well, inside of this byte containing all zeros, we'll send at a specific bit position a positive voltage, and then a negative voltage, and another negative voltage, and then another positive voltage. But we send these bipolar violations at specific bit positions, and the equipment then knows, oh, this is code for here's a byte containing all zeros. And typically this is what we use. We typically say it's B8ZS. Next, let's think about the framing. We've got a couple of options here. Superframe or extended superframe. If we think about it, a T1 frame is 193 bits in length. We've got 24 channels, and we've got 8 bits per channel. That's 192 bits, and then we've got a framing bit on top of that for a grand total of 193 bits. Well, we don't send a single T1 frame by itself, we send it in a group. And if we group 12 of those frames together, that's a superframe. If we glue, if you will, 24 of those frames together, that's an extended superframe. Typically, what I've seen in the real world is extended superframe. It's used much more than a superframe. And there are some benefits to extended superframe that really are not that relevant today. We could do something called channel associated signaling, also known as robbed bit signaling, where we go into every 6th frame and we take one of the bits that's used for voice sampling and we use that as a signaling bit, and that way we can use all 24 channels on a T1 circuit for voice. We don't have to give one up for signaling. That's rarely done anymore though, but typically we still see extended superframe being used as our framing type. The next thing we want to do is to group some of these channels together in a PRI group, a primary rate interface group. And the more channels you have, the more DSP resources you consume. And I've got quite a few DSP resources on this router, but I want to show you how to set up a fractional T1, a fractional PRI. Let's say that we just wanted to use 3 bearer channels. We could do this. We could say PRI group time slots, and we say what time slots we're going to use. I'm going to use time slots 1 through 3. And of course, it's going to use time slot 24 because that's going to be the signaling channel. Let's make sure this controller is administratively up. We can do that by saying no shutdown. And now we can configure that D channel, the channel that carries the signaling, that 24th channel. It's kind of interesting how we get into configuration mode for that D channel. We go into a serial interface. Check this out. We say interface serial 0/0/0, and then we do a :23. Where the number after the colon represents the time slot. Hold on, didn't I say that the 24th channel was the signaling channel? Yes, but when we're talking about an interface numbering scheme, the numbering starts at 0. That means 23 really is the 24th channel. So let's go into interface configuration mode for this D channel. And something I typically do for H.323 gateways is I want this port to be able to send all possible caller ID information out to the PSTN. And I give a couple of commands to do that. I'll say ISDN outgoing display IE, that's information element. I'm also going to do ISDN outgoing IE redirecting number. Now, where that comes in is in voicemail. Let's say somebody calls into my phone, and if I don't answer after several seconds, it forwards off to voicemail. Well, when voicemail gets that call, how does the voicemail server know to direct this to my mailbox? Because the DNIS now, the dialed number, is the number of the voicemail system. The calling number is whoever called me, maybe out on the PSTN, maybe a coworker in another cubicle. How does my number show up? How does it know to go to my mailbox? Well, that's the redirecting number. That's the RDNIS information. If I redirect the call to the voicemail system, it can look at the RDNIS, or the redirecting number, to know to go to my mailbox. So I want to make sure I include that information if I need to send a call like that out to the PSTN. And in order to make a router an H.323 gateway, we need to go into an interface and say that you are the interface that is in charge of speaking H.323 for this router. And I'm going to use my voice sub-interface. It's a sub-interface on a connection that goes out to my switch that has a couple of IP phones attached, and it's interface gigabit 0/0.200. That's my sub-interface. And I'm going to say H.323 gateway VoIP interface. I'm declaring that this is an H.323 interface, and it looks like I already had that command in place from a prior configuration. And I also want to bind H.323 communication to the IP address of this interface, or this sub-interface, because we want to make sure that we're sending H.323 information from the same IP address that we're receiving H.323 information. If you send from one IP address and receive on another IP address, that could lead to one-way audio. Not good. So here's how we bind all of our H.323 communication to a specific IP address. We're going to say H.323 gateway VoIP bind source address, and the address of this interface is 10.10.120.1. And again, this command was already entered from a prior configuration, but that's how we say I want to bind my H.323 communication to this IP address. The next thing I typically do is set up a couple of voice classes. Let me explain. I'm going to say voice class H.323, and I'm going to give a locally significant tag of 1. It doesn't really matter what number I use. I'm going to say 1. And something I like to do in situations like this is adjust the TCP establish timeout. Imagine this. We've got a call coming in from the PSTN over this ISDN circuit. And here at the HQ site, I've got a couple of servers. I've got a publisher server, I've got a subscriber server, which is great for backup purposes. However, let's say that the call comes in and I try to extend the call over to my subscriber and it's down for whatever reason. Well, after a certain period of time, we can set things up such that we will fail over to the publisher. However, here's the issue. What we're going to configure to point to the subscriber and to point to the publisher, we're going to configure something called a dial peer. And this dial peer is going to try for about 15 seconds to establish that connection before it gives up and says, well, that's not working. Let's go see if we have a backup dial peer we can use. Well, the challenge is the ISDN circuit is going to time out after about 10 seconds. So ISDN is going to give up on the call before we ever have an opportunity to fail over to a backup dial peer. So what I want to do here in this voice class is say, actually, if I'm not able to establish a connection with my communications manager server within, let's say 3 seconds, you might do 2, you might do 3 seconds, I'm going to say 3 seconds. If that doesn't happen, then give up. Go try a different dial peer. And to do this, we say H.225 timeout TCP establish, and I'm going to say it's 3 seconds, and I will apply this to my dial peer later on. Let's create another voice class. I'm going to say voice class codec, and I'll give a tag of 1. What's going on here? Well, by default, a dial peer is only going to use one codec. We can configure what codec that is, but sometimes we might need to be speaking G.711. At other times, we might need to be speaking some other codec. We might change mid-call. Maybe we're talking to somebody and we're using G.729. They put us on hold and suddenly that music on hold is G.711. We need to be able to switch midstream. And we're not able to do that with a regular dial peer configuration. So what I want to do is set up a codec voice class that will say, here are the codecs that you're capable of using, not just one. And I'm going to give the 2 that I'll probably be using in our lab topology. I'm going to say codec preference. In other words, I prefer, the lower the preference, the better. I prefer to use G.711 ULAW. However, if that's not available as a secondary codec, I'll say we can use ILBC. Now let's create our very first dial peer. Now this dial peer is going to be for an incoming call coming in from the PSTN. This is usually the first dial peer I create. I'll say dial-peer voice 1, and then I say it's a POTS dial peer. The other option is voice over IP, but this is going to be used by an incoming port, so it's a POTS dial peer. And I want to match any call coming in from the PSTN. And to do that, I'm going to say incoming called-number, and because dial peers use variable length matching, I can just simply say dot. If the dialed number coming in from the PSTN contains at least one digit, then ding, 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 we've got a match. Now, why is it so important that we match that incoming call with this dial peer? It's so we can do this. It's so that we can give this command. We say direct-inward-dial, DID, direct inward dial. What this is going to do is allow the router to look at the dialed number coming in from the PSTN, the DNS information in other words, and it's going to be able to forward the call based on that dial number information. If we did not do this, we would call into this site and the router would present us with a secondary dial tone. What would you think if you called a company and you heard a dial tone when you called in? You would think that your call had been terminated. That's what I would think anyway. You would hang up and you would try again. We don't want secondary dial tone typically, and this gets rid of it. Now I need to set up a couple of dial peers that will get us over to our communication manager servers. I'm going to prefer to use my subscriber because the publisher is busy enough doing other things. So I'm going to say dial-peer voice, and I'll give a dial peer tag of 2. And this is going to be a voice over IP dial peer. It's going to be pointing over to my communications manager server, and it's going to have a destination pattern. Destination-pattern, and here at the HQ side, I've got 4-digit numbers that begin with the 2. Here's how I can specify that. I can say 2 ... 2 followed by any 3 digits, and I'm going to put a $sign after that. That's a meta character that says this is the end of the string. Remember I said we used a variable length matching? If I just said 2 ... Sure, that could match 2020, but it could also match 2020, 2020, 30, 40, 50. It's variable length, but the $sign says that's it. It's only 4 digits long. Now I say, how do I get to this destination? Well, I'm going to point over to my subscriber. I'll say my session target is an IPv4 address, and the address is 192.168.1.72. And do you remember the voice classes we created earlier? Let's apply those. I'm going to say voice-class H323 1 and voice-class codec 1. So now that timeout is applied to this dial peer, and the codec selection is available to this dial peer. Something else I like to do is to set up Dtmf Relay. If we're using some sort of a compression codec like ILBC, while ILBC or G.729, they sound great for human speech, they don't do so great with touch tone information. Those tones can be scrambled up where they're not going to be able to be interpreted by the far-end equipment. So what we can do is send Dtmf dual-tone multi-frequency tones, not as tones at all, but we can send them as maybe text or encoded in some other way. We've got options. Here's what I normally do. I'll say Dtmf-relay, and we've got different options, but I typically use H245 alphanumeric. The reason I use that, and by the way, what this does is it sends the tones as data. If I dial 555-2020, it's not going to send the tones representing 555-2020. It's going to send actual data of 555-2020. Now, the reason I use this is because this is the type of Dtmf relay that our communication manager server defaults to. Something else I usually do is to turn off voice activity detection. No VAD, no VAD. As one of my friends, Vic Marley, says, VAD is bad. We want to turn off voice activity detection. Now, it has a good intent. The intent is to save bandwidth. What it does, it listens to our transmitter on our phone, and if it doesn't hear us speaking for a period of time, it's going to say, I think they're quiet at the moment. They've stepped away. So I'm going to suppress the sending of the sound of silence. I'm going to send nothing. I'm going to save bandwidth by not sending anything because they're not talking right now. The issue is, when I do start talking again, it takes it a little bit of time, just a split second, to realize, oh, they started talking again, I better start transmitting again. And it can clip off the first syllable of what we're speaking, or maybe even worse is if we are sending some sort of tones, it can clip off the first tone. We don't want that to happen. I'm going to say no voice activity detection. Now, this dial peer points to our subscriber. We need another dial peer as a backup that points to our publisher. Let's say dial-peer voice 3. And this is a voice over IP dial peer. And the way I make this a backup dial peer as opposed to the primary dial peer is I set the preference. The preference value ranges from 0 through 10. Lower is better. In other words, 0 is the most preferred. Now catch this. The default is 0. That's right. The default preference is the most preferred preference. I didn't give a preference for dial peer 2. That makes it the most preferred preference. What I'm going to do here is give this a slightly less preferable preference of 1. It's higher than 0, so dial peer 3 will only be used as a backup to dial peer 2. Now I can start giving the same set of commands that I gave for dial peer 2, except I'll give a different session target. But I'll still say that my destination hyphen pattern is $$. Let's change up the session target. Let's point to the IPv4 address of our publisher, 192.168.1.71. I still want to apply my voice classes. I'll say voice class H323 1, voice class codec 1. Let's turn on Dtmf Relay, Dtmf-Relay H245 alphanumeric. That is bad. Let's get rid of voice activity detection. Now we've got our dial peer set up to get us to our communications manager server. We've still got a bit of a challenge though. When a call comes in from the PSTN, it might be coming in from a local number, maybe 7 digits. Maybe it's coming in from a long distance number where the area code is included in the dial string, 10 digits. What we want to do is to strip off those leading digits and only use the last 4 digits to match a phone here at the HQ site. And one option for doing that, the most powerful option in my opinion, is to use a voice translation rule and a voice translation profile. Here's how that works. I'm going to say voice translation -rule, and I'll just give a local tag of 1, and I can set up a sub rule now. I'll say rule number 1, and the way a voice translation rule works is we've got 2 sets of forward slashes. That might be one set, that might be the second set, and whatever I put inside of the first set of forward slashes, that's the string I'm matching, and whatever's in the second set of forward slashes, that's the replacement string. So for rule number 1, I'm going to say /dot, which represents any dial digit, and then I'm going to say star. Now, a star is going to represent 0 or more instances of the previous meta character. In other words, the star says we could match a single character or we could match 20 characters. It's 0 or more occurrences of the previous meta character. So if this dial string is a 10-digit dial string, we match it. If it's a 7-digit dial string, we match it. Star. I'm only interested in the last 4 digits. Now here's how I grab hold of those last 4 digits. I say, we're trying to match a pattern that comes in, and I'm going to put these last 4 digits in parentheses. That's going to be called a set, and we can reference a set in our replacement string. Now the way we put something in parentheses is we have to do a backslash before the open and before the close parentheses, because a parentheses might be interpreted as a special character by Cisco IOS. By saying backslash parentheses, we're saying it's just a parentheses. Don't try to read too much into it. It's just a parentheses. Now what I'm trying to match is $$. The string ends here. I don't care if it was a 7-digit string or a 10-digit string. It ends in $$. And I'll do a backslash close parentheses, and then I'll do another /. That's my matching string. Match a string of any length as long as the last 4 digits begin with a 2. The replacement string is simply going to be give me the contents of set 1, those last 4 digits, and put it here. And the way I say put set 1's contents here is I say /1. I'm taking this string of any length, which ends in 4 digits, and those 4 digits begin with a 2, and the last 4 digits, they're in parentheses, so they're set 1. My replacement string by saying /1 is set 1. Now that I've said that I want to extract the last 4 digits from this dial string, I need to say exactly what kind of translation am I doing. Am I translating the dialed number? Am I translating the calling number? Am I translating the redirected dial number? We can specify that in a voice translation profile. Let's say voice translation -profile, and I'll call this strip because we're stripping off those leading digits, and I'll say that I want to translate, in my case, the called number. I want to translate the call number based on voice translation rule 1. I can now apply this to a voice port. I can say voice-port, and remember we configured controller T1 0/0/0. Well, there's a corresponding port for the D channel. It's 0/0/0:23 because the numbering starts at 0. And we can apply our voice translation profile to this port. I can say translation -profile in the incoming direction. The call's coming in from the PSTN. I want to apply the voice translation profile of strip. Let's save that. And now that we've got things configured on our router, let's go configure things on the Communications Manager server. It's interesting that unlike an MGCP gateway that we're going to be seeing in an upcoming video, an H.323 gateway does not actually register with the Communications Manager server. They sort of just point to one another. The Communication Manager server knows that there's a gateway at this IP address, and the gateway knows that It can forward calls to specific destination patterns to the IP addresses of our communication manager servers. So there's not going to be an actual registration. There's not going to be a configuration file that gets downloaded from the communications manager to the gateway. And that is going to be a bit different with MGCP, which we'll see coming up. But for now, let's educate this communications manager cluster about our H.323 gateway. We go under Device and select Gateway. Do we have any right now? No, we don't. Let's add a new one. And notice we've got all these different models of Cisco routers and platforms. Now with MGCP, we need to be very specific. We need to say that this is a, for example, Cisco 2911 router that we're adding. However, with an H.323 gateway, since there's not that registration that happens, we just very generically say that we're adding an H.323 gateway. And the device name is going to be, since we're not using DNS, it's going to be the IP address of the router acting as our H.323 gateway. And remember, that router, the HQ router, it could have more than one valid IP address. However, we bound H.323 communication to a specific interface. It was that voice subinterface on gigabit 0/0. And it had an IP address of 10.10.120.1. We're going to assign this, just like we would assign a phone, a device pool, so it can inherit any relevant settings from that device pool. Something else that I typically do, if we scroll down just a bit, I typically set significant digits to, in a case like this, 4. We're using 4 digits for internal dialing. Now this is probably overkill, admittedly, because I've already got a voice translation profile applied to the incoming voice port on the HQ router. The digits are already being stripped down to 4. But just as a good practice, if I only want to pay attention to 4 digits coming from the gateway, I'll usually set my significant digits to 4. And here's something that can be overlooked easily. We don't want to overlook it. It's the calling search space. Just like we can assign a phone a calling search space to give it permission to call a certain destination, if we think about it, the gateway is really placing a call as well. A call comes in from the PSTN, somebody's dialing 2001. Well, that gateway is logically placing the call to 2001. It needs permission to do so. So I'm going to give this a calling search space of HQ, and the HQ calling search space contains an internal partition, which contains my internal numbers, and once we add route patterns, those route patterns available from HQ, they will also be assigned to a partition that belongs to the HQ calling search space. And just like we were enabling various caller ID information to be propagated by the H.323 gateway when we were configuring this on the router, I want to make sure that we send caller ID information here as well. Things like redirecting number, IE delivery inbound. Yeah, let's check that. Let me go see if there's another one. Yeah, let's check display IE delivery and redirecting number IE delivery outbound. But I want to back up just a moment and point out something. Notice that we've got an option for enabling inbound fast start, and we've got an option for enabling outbound fast start. Here's my general recommendation for this. I will generally enable inbound fast start, but I will generally not enable outbound fast start. Now, why is that? Why do I not want to enable outbound fast start? Well, let's think about what fast start is. When H.323 sets up a session, it typically goes through several back and forth exchanges between the two endpoints. H.225 is the initial protocol that's used, where one side tells the other side, I would like to set up a call with you, and they agree to set up a call. Then the H.245 protocol kicks in, and they go back and forth and they exchange different information about, hey, what codecs do you support? Oh, I support this codec. How about we use this codec? Okay, that looks good to me. What about the fax rate? I support these fax rates. What fax rate do you want to use? What port number are you going to use for RTP? There are all these back and forth exchanges where the parameters for the phone call are decided upon. However, with fast start, it's much more efficient. There is essentially one round trip communication. The originator says to the destination, hey, I want to set up a call with you. Here are the list of codecs that I support. Pick one. Here are the list of fax rates that I support. Pick one. I'm going to be using this UDP port number for RTP. Tell me which port number you're going to be using. And if the other side is willing to set up a call, it responds with a complementary set of information. And the call gets set up with far fewer back and forth exchanges. So fast start can be a good thing. However, if we say enable inbound fast start, we're suggesting that a call is coming into us. We're not the originator. And if the other side wants to speak fast start, we're good with that. We'll be compatible with that. However, if we say enable outbound fast start, that means when we set up, when we are the originator of a session, we're going to force a fast start to happen, and the other side might not be compatible with fast start. So with inbound fast start, we're being more flexible. We can do regular slow start or we can do fast start for an incoming call. But if we say enable outbound fast start, we might have some calls that don't get set up because the far end does not support fast start. That's my personal recommendation. Well, I think we're done here. Let's go ahead and say save. And here is a big deal. And this is not an obvious thing, but it can really be a head scratcher for quite some time. It's very possible if I try to place a call right now that it would not work. And the reason I say it would not work is because even though I have properly configured this H.323 gateway, I haven't reset it yet. I've seen this multiple times where you have to do a reset on the gateway in order for that change to take effect. So let's do a reset, and now everything should be working. And please keep in mind, we've not yet educated our communications manager cluster with a route plan where we can call local numbers and long distance and international numbers and 911. We haven't done that for outbound calls. However, if the gateway is working, we should be able to receive an incoming call from the PSTN. Oh, and here's something I like to do when I'm testing out these connections initially. Here is my favorite debug command for ISDN. I'm going to say debug ISDN Q931. And this is going to show me detailed information about this incoming call. Let's go over to these phones and let's place a call coming in from the PSTN to one of our HQ phones. Let's make sure it works, and then we'll take a look at the information in this debug output. What we're going to do now is test out our gateway by placing a call from our PSTN phone into, let's go into HQ phone 2. I'm going to go off hook on my PSTN phone, and I'm going to dial 222-2002. And we hear that phone ringing. So we know that our gateway is working in the inbound direction. We've not yet set up call routing intelligence for an outbound call yet, but we know that the gateway is functional. Now let's go back and check out that debug output. Let's take a look at the output from our debug ISDN Q931 command. This can be a very valuable command when it comes to troubleshooting. We can see, for example, that we came in on channel 1. We see that the calling party was 222-2020. That's the number out on the PSTN. And we have an ISDN type of number or ton of subscriber. Typically, subscriber indicates a local call, national indicates a long distance call, and international indicates an international call. There's also a ton of unknown. We might see that with a 911 call, for example. And the called party information is the number that was dialed. We dialed 222-2002. Again, the ISDN ton information was ISDN subscriber. And even though 7 digits came in, remember that we had a voice translation rule that was referenced by a voice translation profile, which stripped off all but the last 4 digits. So what this router did is send 2002 over to Communications Manager, and it knew that number. That is a directory number that is on a registered phone. And the Communications Manager server sent a message out to that phone. It was our skinny phone. It sent a skinny message out saying that it should ring. And here down below we see the various ISDN messages that are going back and forth, where the call is being set up and connected and disconnected. But what we're mainly going to be focused on is this calling and called party information. It's really great to be able to see this information when we're trying to properly format information that's going out to the PSTN. Maybe our local telephone company wants us to send a leading 1 if we're dialing a long distance. Maybe they don't. Maybe they want the ton set a certain way. Well, we can verify exactly what's being sent to and received from the PSTN by using this command. Well, I hope you enjoyed that video showing you how to configure a Cisco H.323 gateway. And if you did, and if you want more videos like that, I've got a video training series. It's the CCNP Collaboration video training series. And what I do there, for each of the 4 courses making up the CCNP Collaboration curriculum, I give you 5 videos like this, highlighting some of the main topics in each of those courses. And if you want more information about that, just visit me over at my website at kwtrain.com/NANP-Collab. That's kwtrain.com/NANP-Collab. Hope to see you there.